So, hello everyone, welcome to CivilPrep. I am Krishna Gupta. So, in this session, we'll be looking at one of the important questions from paper one, that is Geomorphology. In this session of MentorQuest @ 500 Geography Optional Live Answer Writing session, okay, where we will be covering 500 questions in the complete course. So, guys, I would like to remind you, you can join our YouTube channel and you can also join my Telegram group for the discussion of various topics. Now, let's move to the question. The question is compare and contrast the concept of isostasy as postulated by Airy and Pratt. Okay. Now, on the same basis, we'll be seeing that there is a previous year question being asked. Explain the concept of isostasy as postulated by Airy and Pratt in the year of 2012. Okay. Now, here we'll be seeing that when the geomorphology was being developed, so at that time period, there were certain theorists who were looking out for the formation of mountains or the formation of valleys, the different kind of mountain ranges. So during that period, it was majorly seen that the catastrophic school was into the play, and the non-catastrophic school, it was still developing at that time. So here, there was something which was very peculiar with respect to the development of the isostasis concept. So here we'll be seeing that Airy was one of the, we can say one of the geographer, but he was associated with Everest. Okay. So Sir Everest, he was one of the, we can say, uh, he was looking out for the various gravitational fields at the different locations. So at that time, he was present in the Himalayan region and he was mapping the elevation or the altitude of the Himalayas. So there he saw that the gravitational field present at the Himalayan region and the plain region, it is different. So it struck Everest that why this is so. Is it because of the gravitational anomaly? Is it because of the altitude of the mountain ranges? Or is it because of certain other reasons that can be metaphysical? So here, Airy came with the concept that no, it is not because of any metaphysical concept, but it is because of the concept of isostasy. So here we see that isostasy, it is basically referring to the gravitational equilibrium of the Earth's lithosphere. Okay, where the crust, it floats over the asthenosphere. Okay, the crust, it is floating over the asthenosphere. So asthenosphere here will be seeing it is more denser, while the crust, it is lighter in weight, basically in their density. So because of this variations, we have mountains. Okay, we have plateaus. We also have plains and other features. Which is compensated by the crustal thickness. Okay, the crustal thickness, or we can also add here density to maintain the balance. Okay, so from this part, we'll be seeing that we have the concept of the isostasy. Now, here we'll be seeing that there are two models which have been provided. Okay, so here is the question is asking for the comparison and the contrasting the concepts of the isostasy as postulated by Airy and Pratt. So we'll be directly moving to the aspect of the question, that is airy and pratt. So when we look at the Aries concept, it is consisting, he's saying that, okay, let's look at the first concept, what he said. Aries said that if I will take certain wooden blocks, which is having uniform density, so they will be floating over the water. Okay, so here we'll be seeing that the concept is given as uniform density with varying depth. So here we can see the depth of all the blocks that is different, but here the density of the blocks, it is same. Now, in the same way, what Pratt has said, that Pratt did not believe this part here. Basically, what Airy has said, that there is formation of roots are taking place here. Okay, so this root concept, it was provided by Airy, and Pratt said that it is not like that. It is like there are various materials which are present over the Earth's surface, and they are having different densities. Okay, for example, this is D1, D2, D3, D4, and D5. So here we'll be seeing that there is a level of compensation. Okay, here a level of compensation is being formed, and it is floating over the liquid material. So therefore, what Pratt has said, that the Pratt's concept is there is uniform depth with varying density. So this was something which was quite different from the Pratt's perspective. Okay, so here what we will see here, that the thickness which is provided by both the theorists here with respect to the concepts. So it was quite differentiate also. Okay, it was quite different also. As we'll see that Pratt rejected the root formation theory or root formation concept, and he basically went forward with the concept of level of compensation. So according to Pratt, what we see here, that the Earth's crust, it is present almost at a uniform level. Okay, but as per the Airy, there is formation of root. So according to Airy, there was something quite peculiar. For example, the roots for example, he has given a ratio for the crust and root. For example, the Himalayas. Okay, the Mount Everest, if we talk about, it is almost around 8 kilometers. So the root of this crust, it will be almost around 72 kilometers. So it is almost around 1 raised to 9. So this was the principle which was provided by Pratt here. Okay, this was the principle which was provided by Pratt. Airy, that there is formation of root, and this root formation, it is supporting the Earth over the Earth's crust over the liquid asthenosphere or liquid mantle here. Okay, so what he went forward with, Airy and Pratt. So if we talk about the compensation, so Airy has said that there is homogeneous crustal materials over the surface. Okay, for example, mountains, plateaus, plains, all of them are made up of same material. While the Pratt said that all the material of the crustal part, it is made up of heterogeneous material. Okay, for example, mountains, they are of less dense material, while plateaus, they were of more denser comparative, and plains, they were the most dense. So this was one of the concept which was provided by Pratt here, that the material is heterogeneous in nature. If we move forward, if we look at the analogy, so he has also compared this with the iceberg part here. That is an iceberg which is floating over the surface. It is 1 and it is 10 here. And here, when we talk about the Pratt's part, he had considered it with the wooden block. One wooden block is of teak, another wooden block is of rosewood. Okay, another wooden block is of mahogany. So here we'll be seeing that the teak, it is denser, but the densest is mahogany. Okay, it is the highest density. Then rosewood, then teak. Then if we go for the other trees like we can say shisham or babool. So these trees, they have low density. So therefore, they were able to separate their concepts with respect to the formation of the isostatic part here. But when we look at the criticism, okay, we need to also provide the criticism of Airy and Pratt. Number one, with the Airy's part, it was seen that the materials present over Earth had varied densities. For example, basalt, gneiss, then we can have uh, shite, okay, then we have marble. All of these materials have varied density. But when we talk about Pratt, what we will see here, the depth of various regions was different. For example, the mountains, they had varied depth, then plains, they had varied depth, plateaus, they had also varied depth. So here we see that they have variation in the depths also. But yes, there is variation in density, but there is variation in depth also. Not all the features are present at the same level of compensation. So from here, we'll be seeing that we are able to provide the conclusion for this question. So under the conclusion part, we'll be seeing that Aries and Pratt's concept of isostacy gave birth to the concept of varying depth with varying density. Okay, varying depth with varying density. And here one more thing will be also saying that there was crustal bending phenomenon due to the load present over Earth's surface and which was provided by plate tectonics theory. So guys, this is the answer for the question that is asked here. Compare and contrast the concepts of isostacy as postulated by Airy and Pratt. So here we have compared both Airy and Pratt, okay, how they have been looking at the concept apart, different from each other, and how this the crustal bending phenomena was introduced by plate tectonics theory, which provided for varying depth with varying density. Okay, so this is the first question. Now, moving to the next question we have here. Examine the formation of Andes Mountain with the help of plate tectonics. Okay, so there is a PYQ also here. State the concept of plate tectonics. How does it help in explaining the formation of Himalayas and Appalachian Mountains? So just pause the video, write your answer, and we'll discuss this question again. Okay, guys, so let's look at the answer. If you have completed your answer. Now, this question, it is specifically talking about the Andes Mountains. So as the Himalayas and the Appalachian Mountains, their formation have been asked previously. So there are very high chances that the question can be asked on Andes Mountains, Ural Mountains, Alps, Atlas, or we can say the any other mountains of the world, okay, which can be fold mountains, young fold mountain or the old fold mountain. Okay. Now, looking at this aspect here, when we talk about the Andes mountain ranges, so introducing first the Andes mountains present in South America forms a part of alpine orogeny, okay, which took place between the Mesozoic era, okay, and is explained well by the convergence of Pacific, which is oceanic, and South American, which is continental plates under the plate tectonic model propounded by Morgan, Mackenzie, Parker, and Tuzo Wilson. Under the period of quantitative revolution. Now, when we look at this introduction here, this introduction gives us a very good summary of what we'll be writing further. So here we'll be seeing that in this question, we are talking about the Andes Mountain. We are talking about the Alpine orogeny, which took place in Mesozoic era. Okay, we are talking about the convergence of plate, which is oceanic and continental plate, that is Pacific and South American plates, under the plate tectonic model, and the name of the theorists who have propounded this model, and under which paradigm this development of the theory has taken place, and the explanation of the formation of mountain has taken place here. So in this very easy introduction, we are including everything with respect to the perspective, models, and theories. Okay. Now, moving further, we need to specify about the Andes Mountain. Okay, this is equator. Here we have Andes Mountain. Okay. Now I would like to change color here. We will see that in between there are two mountain ranges. Okay. So it is called as, this diagram is very important from the perspective. Here we have Western Cordillera and Eastern Cordillera. And in between that, we have the presence of Andean Intermontane Plateau. Okay, so this is the configuration of Andes Mountain, which is present at the contemporary time. And we can see this in this diagram also. Now, when we are talking about the formation of Andes, so here we need to include certain points here with respect to the what happened in the background. So we'll be giving a very short introduction here. Andes, which are part of South American continent, after breakup from the Gondwana land, moved westward, where the subduction of Pacific plate, which is oceanic and which was also denser, occurred under the South American plate, which is continental and lighter, resulting in the formation, in the initiation of Andes upliftment. Now, when I talk about this particular background, why it is necessary, because we need to provide here that, yes, there was the presence of Gondwana land and South America. It was part of Gondwana land and it started moving westward. Okay, there was subduction have started here. So here we'll be seeing that this has resulted into the formation of this particular mountain ranges here. So what we will be seeing here, if we look at, when I'm talking about the Pacific plate, it is basically the Nazca plate. Okay, here also I'll be writing that is Pacific. It is part of the Nazca plate, which is a minor plate, and it is majorly the part of the Pacific Ocean. So here there is presence of Nazca plate, and here we have the presence of South American plate. Here, this is the part of mantle. Okay, this complete region, it is asthenosphere. And here, if we look at, there is mantle currents are flowing in the convergent manner. So here in this diagram, we are able to explain asthenosphere presence, the presence of mantle. Okay, and what is happening here? Because the Nazca plate, it is under the ocean. It is consisting of certain parts of water also. Okay, so as the water is mixed inside the mantle, it is resulting into the formation of the magma. The magma is formed because its melting point is declined. Okay, resulting into the formation of mountain ranges, which is initially the volcanic mountain ranges. Now, this is the first step which we see that, which has occurred almost around 70 to 75 million years ago with the initiation of the formation of the Andes. Now, here we need to have a note here. So what is the note? During the initial period, the rate of subduction of Nazca plate was very high, due to which, sorry, it was very slow, not high. It was very slow, due to which there was magma. It resulted into the formation of mountains. Okay, whatever the magma which was outpouring here, it resulted into the formation of mountains. Now, in the second step, we'll be seeing, okay, that is the formation of Andean intermountain basin. Now, I'll be drawing the same diagram here. Or I can just pick it up from this part also. We need it a bit bigger here. Okay. Now, what is happening here will be seen as the subduction of the plate. As number one, the Western Cordillera has formed now. Okay. Now, number two, the Nazca plate, which is subducting, its rate of subduction increases. And as this rate of subduction it is increasing, here we'll be seeing that this Nazca plate it is moving forward, and here there is formation of magma. So magma is forming here. It is resulting into the pushing of the crust upward. It is resulting into the pushing of the crust upward. But it has not resulted into the formation of mountain. Thus, mountains are not formed. Instead, the inter-mountain plateau is formed. And this actually occurred around 45 to 50 million years ago. Now, after the second phase, there is third phase. Okay, under the third phase, we'll be seeing that the formation of Eastern Cordillera. Okay, so under the Eastern Cordillera, what happened next? As the plate, it moved further. As the Nazca plate, it moved further. There was provision of magma here. But what happened here? The rate of movement of the plate, it slowed down. So as the plate slowed down, there was again formation of the mountains. Okay. So here we'll be seeing that the rate of subduction of plate or Nazca plate, it declined again, due to which there was accumulation of magma resulting in formation of Eastern Cordillera. Okay, so in this way, we'll be seeing here that there is formation of Western Cordillera, Intermountain Basin, and there is formation of Eastern Cordillera. And this took place almost around 30 million years ago to 40 million years ago. We can also put it up to 25 million years ago. So during this time period, there was formation of the Eastern Cordillera also. So we will see here that in this way, as explained by plate tectonics, there is formation of complete Andean mountain ranges which underwent differential stages of Nazca plate subduction and which influences the local topography, culture, agriculture, and economic activities of Andean mountain ranges. So guys, this is the conclusion for this answer, where we are able to very well explain in the part of introduction that what is the Andes mountain ranges, what is alpine orogeny, the subduction of Nazca plate and South American plate is taking place. Uh, Here we can also see that this is under the plate tectonics model as propounded by Morgan, Mackenzie, Parker, Wilson under the quantitative revolution. Then we are here seeing that the structure of the Andes mountain consisting of Western Cordillera, then Andean Intermountain Plateau, then Eastern Cordillera. Then here we are seeing that first with the formation of the Western Cordillera. Then in the next phase, we are looking at the formation of the Andean Intermountain Basin, okay, which is present here. Then there is formation of the Eastern Cordillera. Then we are concluding here the answer with the complete formation of the Andean mountain ranges with the help of plate tectonics and how this plate subduction, it is explained well and it is influencing the local topography, culture, agriculture, and economic activities of the Andean mountain ranges. Okay. So guys, this is the answer for this question. So guys, see you in the next session. Thank you very much.